Hey everybody, Scoutcraft here again. Today I want to pick up on a couple things we did. Good friend of the show, Wyatt, had mentioned when we did the Dremel show, he said that he didn't know, and a lot of other people didn't know they made a router attachment. But I wanted to go through this before anybody went out there and picked one up because a couple things you should know about it, and I thought I would just go over it real quick. Now, when I first started off into this whole do-it-yourself thing and kind of hobby making and whatever, I remember one of the things I bought was a router. Okay, and a router, when you are doing woodworking, this is like the next step up into the big stuff, you know, when you get a router. And what a router does, it's a high-speed motor, spins at about 20,000 RPM, and it spins these bits here, and I'll show you what they look like. Now, a router uses what's called a router bit, and this is what they look like. They're 1/4-inch shank here. That shank meaning the top that goes into the machine, and then from there you have different cutting bits. These make slots. This will round over the edge of a board similar to this. It'll make a round over. This here will trim a flush cut, like if you're doing for micro. There's a whole bunch of different router bits you can get into. But now if you remember these here, these are the bits that the Dremel used. These are 1/8 of an inch bit. Now, you remember that these are half the size of these as far as shank goes. This is 1/8, this is 1/4. So there's less deflection. Now, deflection is today's topic. When I was younger and I started to get into woodworking, I used to go to these woodworking seminars. You go to any of the woodworking shows, they usually have seminars that they have. And in these seminars, there's a wealth of information. One of the things I learned early on was about rigidity. Now, you remember how I keep talking about rigidity, you're like, enough with this, but it's really important, and let me tell you now, why. I thought I was hot stuff because I had this router, and I said, oh, yeah, it uses, you know, I can use a router bit. These bits will, you know, do the job, but the problem is that they are 1/4-inch bits, and when you start getting into the good stuff, you know, the guys that really get the smooth finish, and you try and figure out, you know, what do they do different? Turns out they don't use 1/4-inch because there's too much deflection. They use a bit that has like a 1/2-inch shank, like that looks like this. So their router bits are looking like this. Mine are looking like this, and you saw the router bits from the Dremel were looking, so the thicker, the stronger the metal, the better the cut. So instead of trying to adapt the Dremel to be a router, if you can afford it, and it's not expensive now because these have really come down, is to get what's called a trim router. These things are fantastic. This one here is a porta cable, but you can get these, you know, the Asian ones that they make, and they're basically all they are. It's a bigger motor, but it uses a 1/4-inch bits, and that'll be so much better for any kind of work like that you do. And this is just like a router, but it's small. They use it for trim work, but anything you were going to use that Dremel for, you could use one of these. I've seen them go as low as $25 for some of the knockoff ones, but a trim router is the way to go instead of trying to make a router out of the Dremel. The attachment will cost you just as much as getting one of these knockoff motors, but that's the way to go, again, because of rigidity and the deflection. Now, we've all experienced simple deflection before, and the simplest form is, I'll show you on this drill. We're trying to drill into a piece of stock here, and look what happens. Now, it's obvious there's no way that you're going to get this drill here to start a hole on this hard metal, whatever. So we use either a center punch to make a little dimple, or we use a center drill to do the same thing. We make a little hole, and then we could drill in. However, you might have started, we may be able to start the drill. That doesn't mean that this drill will not travel, will not wander. That means it'll go in one way, you know, go in, let's say centered here, but it might come out over this way because it could wander within the hole. And there's a lot of reasons that might happen. One could be because of the grind. It's not grind exactly right. Another one, there could be sideward lateral pressure. So just because you're starting a hole in the middle here doesn't mean it's going to come through in the middle on the other side. Some of the things we could do to stop the wandering of a drill or any other tool is to shorten the length, because the shorter it is, the more rigid it's going to be. You know, the longer this is, the harder it's going to be to keep it straight. And here's the same size bit in two drill. You can see the length. This is called a stubby length. And anytime you're going to be drilling a hole that's a ½ an inch or less, there's no reason to have this huge drill bit. So I bought a whole set of stubby drill bits just for that purpose. Now to show you, give you a demonstration of deflection, I marked two lines identical here using the caliper and scribed it across. There's a line on the bottom, there's a line top. We want to drill through. Now, if we can drill through, we want that line to come, that hole should come directly through that line right there. But this is maple, and maple has a lot of grain. You could see here the grain that runs across. It's a hardwood, and there will be some deflection. And by using the wrong drill bit for this, you know, we're going to use a extra long drill bit, and I want to show you the deflection, and we'll use the drill press just so you can see it's not. Now you can see we're set up in the drill press. Everything's fine. The bit is sharp and everything, but we're just going to run this through and take it and see where it comes out on the bottom. Okay, if you look here now, that is our entrance hole. It looks centered pretty nice on the line. But if you look at our exit hole, you can see it is definitely over. It's not centered on that line, and that can make a big difference. Now, this is only 1.5 inches of travel that I had to go through. So you can imagine if there's that much deflection for something as simple as wood, you can imagine that drill bit can, you know, the longer you could go, if it kept going on this path, it might come out at the edge or something. So that's why I purposely set this up for a fail, but deflection is a big thing that you should keep in the back of your mind. You always have to be leery of this, and there are ways to deal with it. And I'll show you, using that same drill bit and the same piece of wood, I'll show you how we can, if we had to go straight through that piece of wood. Let me show you how we do it. I have another piece of maple, and what we did is I scribed a line, and I marked a hole, center punch on each side, exactly the same spot, and we'll drill in halfway. You see I have the drill press locked down at a halfway point, so we'll drill half from this side, flip it around, half from this side. They'll meet in the middle, and then you'll have a hole that passes through where you want it. Okay, now you can see we have that hole directly in the middle on this side, directly in the middle on this side. So that's a good way if you ever have to drill a hole through a long piece of wood and make sure it comes out centered or something like that. So always keep that in mind when you have a reduced shank bit like this. These are nightmares. This is called a silver Deming bit, and you know, especially one like this. This thing drops down like 1/4 inch and going up to 1/2 inch. This thing here, these spade bits, they can be troublesome too because of the narrow bit in here. So there's always going to be chatter and sometimes a rough finish anytime you're dealing with that kind of deflection. So keep that in the back of your mind. Okay, I think we have time for a quick restoration, being that's what most of you tune into this channel for. Now, this one here is a Channellock. Channellock has an amazing history. You know, in 1886, a gentleman by the name of George Diamant, he was a blacksmith out of Pennsylvania, and he used to go with his wagon from like town to town selling tools out of his wagon. And I don't have to tell you where Channellock is now. I mean, it's a big company, but this is a 420 model. And let me just show you here. I'm thinking this might be a date code here, the CE. I don't, because I could see the offsetting of the stamp. You see the C is a little lower than the E, so that would give me an idea that's a date code of some sort. But you can see the condition these are in, you know, the rust here, okay, and you know, the pitting, and over here the pitting. Look at that. Remember that pitting, because you know what we like to do with that. And you know, they use the nut here that's peened over, you know. And now I have a pair, happen to have a pair of, this is the 430, which is just a slightly bit bigger than the 420. You can see here's the 420. You know, they go in sizes all the way up, but this one's just a little bit bigger, a little bit more stout. This is an older one, but you can see here they use the rivets, so it's not that old. When you see rivets instead of a nut and bolt, that's a newer design. Is there anything wrong with it? Well, here's the problem. You can see over time, these tend to wear out a little bit. And how they wear is, even though it might only be a fraction of an inch, you can see what happens. You know, they get wobbly, and look what happens to the jaws when you try and they try and meet. You might get a little bit of play from side to side. So with the nut and bolt, you can tighten this up, take away the play. With a rivet, you're gonna have a little bit more difficult time. But anyway, let's get started on these. This should be a quick, fun project, and we'll see what we can do. Okay, with our post-wire brush evaluation, you can see here, you know, always getting this nut off is always a trick, but the main thing is you got to make sure you can get that nut back on here before it's on the wrench. You got to clean up the edge here, because remember, it was peened down so it wouldn't fall off. So you got to take it to the wire wheel and just get those threads good again. The wire brushing took all the surface rust off. You know, this is some high carbon steel, and you can see because of that there's a lot of staining. You could see the staining in the metal, and you could also see here the pitting. There's a lot of pitting in the metal throughout the whole wrench. There's some look at that, some deep pitting, but that's to be expected, you know, it's an old wrench. But here, look over here, you can see I found the US and Canadian patents on here, and the wrench says 1957. You can see that right there. So this wrench was at 62 years old or so. So now what we're going to do is we're going to take it over to the sander, and we're going to see if we can't get some of this nice metal underneath to come through. Now, you know my favorite part. Remember what this looked like before we started. And we're calling this wrench done. You can see how nicely this wrench came out. This 1957 Channellock model 420. And you can see the polishing, and you remember all the pitting that was involved in the handles and everything. And everything is so nice and smooth now. Everything's polished out and inside and out. Very smooth to operate. All 5 positions, very little wobble now, hardly any, but still nice and smooth. The nuts all nice and polished out. Just a nice wrench, you know. Again, 1957, they didn't have the blue coating that Channellock is known for today, and the 420 was a very popular model. It was, like I said, a 5-position wrench. The 430 was a ½ inch bigger, and that's a 7-position wrench, so that's a little bit different. It would have 2 more grooves down here, a little bit bigger. But this was a popular wrench, and rightly so. It's a mainstay for a lot of different plumbers, mechanics, things like that. But anyway, this was a fun restoration, a 3-hour restoration, believe it or not, for this this wrench that really isn't much of anything. But hope you enjoyed it. Thanks very much. I'm going to have a special announcement for an upcoming show right after this. So again, take care and have a nice day. Bye-bye. Now this weekend, for any of you that are in the Pennsylvania area, in Bangor, Pennsylvania, the Jacktown Steam Show, I'll be there on Saturday. We're going to meet up at the Big Gazebo at 11 a.m. on Saturday. So hope to see you there. Take care now. Bye-bye.